Today we are going to turn this 1541 into a disk drive for the PET. Let's do this. So that is the build of this little board that gets stuck into the 1541, and we will have to build the cable now and try it out. Let's build a cable. So if you take a closer look at this board right here, you can see that it actually has printed 1 to 12 and 13 to 24, and that is where this connector goes. And I'm using these breadboard cables just to plug in here, and these ends are not used right now, so I'll have to cut these or strip these and connect this to this ribbon cable. And on the other end, the standard IEEE connector is this one, and I actually ordered this one, but if you look closely at the PET, there's no place you can put this, because the PET does use this kind of connector, so you plug that into the user port. Yeah, we will salvage this connector, and we just have to open this, and then you can create one of these builds yourself. So this just opens up. I will also salvage the casing. And as you can see, it's just a standard reset switch. We will not use this. Have to desolder the connector here and here. It's double-sided. And then we will solder the ribbon cable to this. And the other end of the ribbon cable goes to this. And then we have a cable. And we do a 1-to-1 connection. So on this connector, if this is the top side, this is 1 to 12. And this underside is 13 to 24. So pretty straightforward, just solder 1 to 1, 2 to 2, and so on. Okay, so let me quickly desolder this connector, and then we will take care of the cable. Yeah, there we go. Okay, nice. So I guess this will go in the parts bin, and we have a connector. Very cool. And this is also labeled, but it's labeled 1 to 12 and A to N. Let's first go and wire the ends of this to the ribbon cable so that we have an actual cable to attach. And I did use the same colors, so if you check the colors of the ribbon cable, you can see, no, the other way around, that these match the other colors. It's orange, yellow, green, blue, purple, gray, white, black, brown, red, orange, yellow, and the same on this, so that there's no confusion. Just pulled one of these connectors out, and they are just put on here. And to give this a bit more sturdiness, I will go and use some electrical tape and create a one-piece connector by just wrapping the electrical tape around. You can also use a connector if you have one, of course. That is my cheaper way of doing this. And we have a nice connector. So these individual cables won't come off now, which is just what you want. And we do need some length of cable here, because this board sits inside the 1541, and we have to get the cable out of there and into the PET, so this is not enough. So that's the cable stripping. Now let's strip the other end. Okay, cables are stripped. Let's put on some tubing, and then we will solder these cables together, and then we will have a nice ribbon cable. And yes, that might not be the most effective way. If you have a one of these crimp things. You can also create your own connector and crimp the cable directly to the connector and then put it on the board. But since I don't have one and I don't want to solder to the pins directly, this is my way of doing this. And as always, there's always better or different ways. Do what suits yourself. Okay, so we have a nice shrink tubed bundle of cables, and now we are going to connect these to the ribbon cable. Then we are going to put all the cables into some solder grease, and then we solder them together. So let's start on this side. I'm just twisting the cables together, and then we're putting this twisted end or ends into the solder grease. Okay, I think I will solder these first because they are not too stable, so don't want to do this over and over again. Doesn't need much, just so they grab the solder a bit better. Let's continue with the other. Okay, so first half done. I think I will, still hot. I will use some electrical tape to put this a little bit together and also add some stability to the connections. Okay, so that is that. And since we know exactly which color is which, because we have the same order of wires, this is not a problem. So we have a nice long cable which will then go to the connector. And now we do the same on the other side. Yay! Okay, so the ribbon cables are attached. Okay, nice. So if you take a look at this schematic from the backside of the PET, you can see this is exactly what we saw. So this is if you look from the outside on the PET IEEC port or IEEE488 port. But if you have a look at the connector, which plugs on like this, this starts with 12 and goes to 1. So I think we have to connect the 1 from here to the 12 here and the 2 from here to the 11 from here. So I will do that because that is how this is supposed to work, I think. But we will see about that. We have the pin out here, and it says upper pins, data, end of identity, data valid, not ready for data, data not accepted. So all kinds of status information is put on one of these pins. And we have a pure data connection. So I guess there's no voltages going around here. And that would again mean that even if we solder this wrong, there should be no damage to the PET. Just doesn't work. So okay, I'm willing to take that risk. Okay, so let's solder the connector. Oh wait, I just noticed something else, and that is if you turn the connector around, you have 1, 2, 3, the right description. It's just printed upside down then. But this is how this is supposed to work. So 1 is 1 and 2 is 2. Sorry for the confusion. Like this. And we have our top here. And it wasn't too smart to put the one down here because that is where I will strip the cable. So let me quickly mark the one up here and the one up here. Okay, so again we will separate the cables and we will strip the cables and we will solder the cables. So that will be a montage. Okay, cables are stripped. So let me quickly check. This was number 1 and it is. So let's go and solder some cables, I guess. Make sure that you stick to the order of cables when soldering. Okay, first row is soldered, and put something between those pin rows, and maybe I bend the pins outside a little more so that these don't make contact. Okay, that looks nice. On to the next one, and then we have a working cable, I hope. We'll see. Okay, now we start on the other side because A is now on this side. And that makes total sense. And now also the print is the correct orientation. I'm an idiot again for not thinking ahead a little. How this works when it's getting soldered. Sometimes I surprise myself and not in the best possible way. Okay, second cable is on. Looks good. Just hope it works. So this is how our connector looks. Looks quite nice. Just have to remember where the top side is. It's this one, and we will write that down immediately. We have oben, which means top on this thing here. Don't know if the connector fits in here, but it should. Yeah, it does. And it's even held in place. That's good. So I guess we will use this. Oh, look, even the cables come out nice. That's cool. So, okay, there we have our construction. So now we have to do the EEPROM burning, and yeah, let's do this next. Well, hello there. While editing part 2 of the 1541ToPET video, I noticed that I have no footage of me burning the kernel EEPROM. So I did a video about burning a kernel EEPROM for the SpeedDOS disk drive, and I did a video about burning a C64 kernel for the C64 handheld. So I will link this video in the description below, and you just use the bin file, which is also linked in the description below, instead of the C64 kernel, and away you go. So here's a finished board, and you have to put the 6522 from the 1541 in here. This plugs in that place on the board of the 1541. You have a few ICs here which do the heavy lifting on the IEEE 488 side, which is the 751608, which goes here, which is the 751618, which is right here, and the 47LS136, which is here. So yeah, I only have one of these, and I already have one of the interfaces plugged into the 1541. So let's take a look inside the 1541 and see how this assembles. So this is the 1541, and I did already replace the 6522 with the adapter board, which is just like this. Plug it in with these pins there, put the chip in here, and this is also equipped with the 751608. And yeah, here's the cable which goes to the PET, which goes over there. And that is pretty much all there is, except for the kernel ROM, which is here. You can see there's an adapter in there, and that is my self-burnt EEPROM. Yeah, and that should do the trick in making this work. So let's put the lid on and let's see if it does. Okay, my 1541 with a new interface is connected. You can see it in here. Let's open this up. You can take a look at it. There's the interface, new kernel, and let's power up the PET. And I have a DOS 4 PET here. And let's first try to read a C64 disk. So this should able to read C64 or 1541 formatted disks. So the command we have to use, I have a little cheat sheet here for the commands. So there's let's maybe first check the status of the last disk command. So that can just be done by typing print ds string, and it says here 73 IEC DOS version 2.6 2031 0000. I assume this is a version, this is a kind of disk drive which it thinks it is. I have no idea. Good. Next up we have a directory command, and you can get a directory command, a directory of the disk by typing directory or the classic C64 style load string, (8). The directory command has the advantage that the program in memory will not be deleted. So let's use directory, and away we go. And it says Deutscher C64, lies mich C64 Deutsch. So this is actually a C64 or 1541 formatted disk with C64 programs, which of course we can't run here because we're on a PET. So that works. We can do, let me quickly show you, do the same by typing load $8. No, we can't. Why can't we? Just worked. So I did test all of this. Oh. Now it does. And as you can see here, we get the complete story. By typing directory, it broke off on the line here, so it didn't get that, I think. So that directory command doesn't recognize these lines, and then it breaks. And if we type the classic load $8, we get the full directory. We can show you again. If we type directory, and now it works. That's strange. Okay, so never mind. But we didn't see all of these before. So yeah, seems a bit flaky on the directory stuff. So next thing we have to do, we have to format a disk, and this is kind of a blank disk. I'm always checking for disk rot, so what I do is I take the disk and I turn it manually to see if there's some disk rot on there. Disk rot is pretty much disintegrating or disintegrating plastic or magnetic coating or whatever. So we can't format with the classic open 15,8, 15 and then the N0 disk whatever close 15. That doesn't work here. So what we have to use instead is the header command, and that goes like this. You say header, you give it a name, let's say disco is the name of the disk, then you type comma I01, which I guess is kind of the device, and D0 is the drive you are you want to format. So if you have a double floppy, there could be disk 1 or disk 0. Are you sure? Yes, sir. And away we format. Hopefully. Yeah, it's clicking. So that seems to format. Okay, here we are. And now we can do the classic directory. And 664 blocks free on disco. Yeah, worked. Great. So I have this device configured as device number 8, and I have my PET disk max also on here. So this is actually running daisy chained on the PET disk max. And we can now copy files from the PET disk max to the real disk drive. So that is interesting. So let's do load $9, because that should give us the PET disk max directory. And there we are. You can see here there are different programs, and let's go with dungeon. So we say we can say load, or we can say deload. If you say deload, it always defaults to the device number 8 disk drive 0. So if you just go for deload dungeon, that doesn't work. So we have to actually load, because we have to tell it. Don't know if you can use oh wait, maybe we can check that. You can load, use deload, 9 to just load from the other device. Let's see. No, you can't. Okay, so load dungeon, 9, and it loads, and we don't hear anything. And as you can see, it's still blinking here. And we have a dungeon in memory. Stopping this. We can say dsave, because now we are actually saving to the disk right here, number 8. And that should, it's still blinking. I'm not sure if you have to first reset it. No, it's saving. Yeah, it's making some squeaky noises, so I have to maintain that drive a little. And so we are saved to disk number 8. So let's check if it's really on there. Let's say directory. And there's dungeon on our freshly minted disk. And let's say deload. And A is still stuck. Dungeon, that should now load from disk 8. So device number 8, this one. And it does. And here we are. Let's run this. And there's Dungeon by Brian Sawyer. And that is a pretty interesting game, because it always generates a new dungeon whenever you start the game. So that takes about a minute to set up, and then you have a new game every time you play. That's pretty much all you can do with my Commodore 64 or 1541 2PET interface. Works like a charm. Don't know if the glitching is due to the fact that I daisy chained it to my PET disk Max, or it's just the way it is. But however, I'm pretty happy with it. So now I have an actual disk drive that works with my PET, which is pretty cool. And if I want to have a 1541 again, which I have loads of, but if I want another one or this one reversed, I can just pull the board, put the chip back in and switch the kernel, and away we go. Yeah, so while I was talking, Dungeon has set up. So we're using the cursor keys for movement. Oh, that was an attack. I'm attacked by what? So that concludes my video on my 1541 to PET interface. If you want to build one yourself, I will put all the links in the description below. So thanks for watching, and until next time.
Thank you for watching Retro is the New Black. If you're new to the channel, please like and subscribe. If you like the video, please share. Every like, share, and comment helps a lot. Until next time, bye-bye.